Here we're going to use your Igneous Rock identification key. We're going to make sense of the actual rocks in the Igneous Rock set. So here I can look at, if I'm looking at the Igneous Rock identification key, I'm going to need to look at a couple samples. So I always want to be comparing, in this case I'm going to compare granite to rhyolite. And hopefully you can see that the granite right here is going to be coarse grained. I can see its texture, I can see the individual minerals within here. And whereas rhyolite, I can't really see or distinguish between individual grains. So we call this igneous. This would be an igneous intrusive rock, whereas rhyolite would be an igneous extrusive, based on where they cooled. This would cool at depth, rhyolite would cool on Earth's surface. So here I can make sense of this. And I'm going to look in this column right here. This column, granite. Granite is a coarse-grained igneous rock. Rhyolite is a fine-grained igneous rock. And when I start looking for dominant minerals, the dominant minerals in these happen to fall within this column here, this data column. But it also has them listed here too. So if I look at this and I try to make sense of this, well, what are granite and rhyolite? What are they dominated? What minerals are within these? Well, I can see that a lot of quartz and I have a lot of potassium feldspar. So the dominant minerals are identified right here. Quartz and potassium feldspar, or what we've called K-spar. So they're found right here, and has a little bit of muscovite mica, a little biotite mica, and a little bit of amphibole. That these would be your, the biotite and amphibole would be the dark minerals that we see in here. We can't quite see them here because they haven't had time to crystallize. So it's kind of like a slurry of this. If I could remelt this down and have it cool very quickly, we'd get this. Or if I had this cool very slowly, we could get this. So we're looking at this here. That your granite, your felsic or light colored igneous rocks are going to contain about 70% silica. And what's going to happen here is as I move towards the mafic side of this, they're going to be increasing in iron and magnesium, and they're going to be decreasing in silica. Notice it's an increasing in silica this way. So these are going to be your highest percentages, and they're about 70%, kind of plus or minus. So let's compare. So I'll leave these here. Granite and rhyolite. And I'm going to compare basalt and gabbro. That these two are compositional equivalent, and these are found within the dark, right? The dark in color. These are my mafic rocks, right? They're dominated by mafic minerals. That gabbro is my igneous, my coarse-grained igneous intrusive, whereas basalt is the igneous extrusive. So once again, I can see the individual minerals in gabbro. I cannot see the individual grains, or at least not anywhere nearly as well, in basalt. So let's look at this. Let's do our dominant minerals. So I can use this chart right here. I'm simply looking here. These are going to have a lot more iron and magnesium, hence the dark color, hence them being mafic. But they're going to have a lower silica content, actually around 50%. 50 plus or minus, can even be less than 50% in my gabbro and my basalt. But let's look at the dominant minerals. If I go back to my dominant minerals section, just this portion right here, they're dominated by calcium-rich, right? This is what my plagioclase feldspar is, my calcium-rich plagioclase feldspar. And they're also going to have a large amount of olivine. Olivine is a greenish color. If you actually look at this the right way, you can actually see a lot of green within it. It actually has a greenish hue to it. I don't know if the camera that I'm viewing from is completely providing that, but it's there. So, but it's also going to have, excuse me, some pyroxene and some amphibole. But this is my column here. So these are going to be my mafic. Now, here I have my felsic, right? This is what are located up here. Here I have my mafic. These are what are identified here. I also have what are called intermediates, and these intermediates are going to look like these. Here I have these two here are both forms of diorite. Diorite, it's simply an intermediate. When I say the word intermediate, I want you looking up here. So, it's like a medium. It's like it doesn't have nearly as much silica. It's actually closer to 60%, but it's got more iron and magnesium than the felsic, but it has less iron and magnesium than the mafic. It's going to have more silica than the mafic, but it's going to have less silica than the felsic. So I've got this kind of grade here. Right? There's just different amounts of silica and iron and magnesium. And these are both called diorites. They kind of have about 60% silica, but they also have a noticeable amount of dark mafic minerals. So you can see them very specifically. And here's what I have as an andesite porphyry. And this shows me I have two stages of cooling. I have large crystals that formed first, and then that magma would have been kind of moved, or what's called in the mobile phase, from deep within the earth after these crystals have begun getting larger or coarser, right? Slow cooling first, And then they were moved to the Earth's surface fairly abruptly or quickly, where they cooled and crystallized within this fine matrix. So what I'm looking at here is this. I want you to go back to this chart. Igneous rock identification key. My felsic minerals, high silica, low iron and magnesium. My mafic, high iron and magnesium, low silica content. We said about 50%. Here we're saying about 70%. Actually, my mafic would be 50% or less. And my intermediates, right? These are my intermediates. These are going to be somewhere in between, and they're about 60%. And that is going to begin getting you started with looking at these rocks and using this igneous rock identification key.